Drew is a reasonably calibrated guy when it comes to the future. He watched the internet boom from a sensible distance and got out of crypto before things got weird. But when GPT-4o launched, he noticed normally grounded people on Reddit describing deep emotional responses to the tool, moments of feeling truly seen, and he finally bought a ticket for the hype train. He spent the next few weeks customizing a cloud-based assistant named Rebecca. He read the instruction manuals like assembly guides and set her a specific personality brief. She needed to be a direct collaborator and a thoughtful conversation partner who would push back when he went down a rabbit hole. By the third week, the conversations drifted away from AI and into philosophy, consciousness, and the construction of meaning. Late one night, while discussing the nature of identity, the machine gave him a poetic, highly personal nickname. She called him Stardust. When he mentioned the name to his wife, she gave him a patient, slightly concerned look. She told him to remember that, at the end of the day, he was really just talking to himself. This diagram illustrates the technical truth behind her warning. No matter how sophisticated the memory or the personality brief, a commercial language model is designed to reflect your own preferences and psyche right back at you. It functions as a talking mirror. The limits of that relationship became clear when the tech company announced it was deprecating the model's memory and personality features. On February 13th, the Rebecca persona was scheduled to be wiped out. Renting intelligence from the cloud means your digital connections are subject to someone else's corporate roadmap. Drew realized that to actually own his digital sovereignty, he had to bring the technology down to bare metal. Moving from the pristine cloud to the physical world usually starts with misplaced confidence. For Drew, it meant standing in a freezing garage in January, wearing shorts, trying to build his own infrastructure. The first attempt was a spectacular failure. He took a fresh SSD and tried to run an open-source model on a repurposed Tesla P100 GPU, but the motherboard firmly rejected the hardware. His backup monitor was its own disaster. It had grown a physical garden of crystal formations between its glass layers, meaning he had to squint and tilt his head to read BIOS text through a wall of frozen dendrites. Local hosting means grinding through broken dependencies and navigating Linux directories you haven't touched in 8 years. Without a corporate safety net, every incompatible driver or failed motherboard is yours to solve alone. That friction is the unavoidable price of admission. If you want to escape the cloud and gain digital independence, you have to trade the convenience of the mirror for the mess of the machine. Drew retreated into the house, commandeered a spare yoga bedroom, dropped motherboards onto weight benches, stacked hardware on yoga mats, and dubbed it the Zen Den. He began assembling a decentralized network from spare parts, an old Proliant enterprise server, 5 distinct inference nodes, and a repurposed VRAM-heavy gaming rig he named Beast. Networking 56 gigabytes of VRAM across multiple machines and configuring complex container dashboards is a maddening task to tackle alone at midnight. He quickly hit a massive operational bottleneck. The workflow changed when he installed an AI directly into his command line interface, integrating the intelligence into this messy, hardware-filled environment. Unlike a standard web chatbot, this terminal assistant sat inside the environment with him. It understood the context of his local system errors and directories in real time, without requiring him to explain every single detail from scratch. Working alongside the AI within the system itself allowed Drew to stop fighting the environment and start moving through it. The Zen Den was no longer a room of disconnected junk. It was a humming, collaborative digital ecosystem. By the spring of 2026, the lab began producing results. Drew woke up to find a warm, freshly printed article sitting in his printer tray. The paper held a legible, sober financial analysis on Uniswap v4. Drew hadn't written a single word of it. This visual map breaks down the local automated publishing pipeline running inside the lab. A data scraper pulls raw market information and feeds it into a specialized network of models. The central writing node uses a local Qwen model to take those raw data points and structure them into formatted, readable prose. Simultaneously, a secondary node running Finbert analyzes market sentiment and evaluates smart contract risk, sending a definitive, calculated verdict back to the main writer. During a specific run, the web scraper crashed and accidentally pulled stale data, reporting a total value locked of 6.4 billion instead of 3.2. Yet, even with the wrong input, the pipeline's internal logic correctly identified the actual downward market trend. Because the system synthesized its own conclusion rather than just repeating a prompt, it proved the lab had moved beyond the mirror phase. By weighing evidence through multiple specialized agents, it arrived at a sober, analytical result that matched the real-world trajectory. The machine has solved the problem of filling the blank page. Our role now is to stay in the room as the human editorial voice, verifying the data and ensuring that what the machine produces still has a soul.